So we are going to discuss about dimensional formulae. This topic is connected to +1 syllabus and +2 syllabus. Total 2-year syllabus. This topic is connected here. So now first before entering to this dimensional formulae, let us have the discussion related to what is the dimension. Dimensions. Dimensions of physical quantities. What do you mean by dimensions of physical quantities? First we have to know. Here they are telling that generally fundamental quantities. Fundamental quantities are raised to, that means if you take any fundamental quantity, that is like mass. What are fundamental quantities, beta? Mass, length, and time, temperature, thermodynamic temperature, electric current, and quantity of substance. So if you observe, these are the fundamental. Again, one more thing is the luminous intensity, but most will be using this. So what we are using? Mass, length, time, temperature, electric current, and quantity of substance. Quantity of substance. So generally we are using these things when we are discussing the fundamental quantities. Fundamental quantities. In fundamental quantities, dimensional formulas when we have to connect. So mass, length, time, temperature, electric current, quantity of substance. These we are using beta. Now observe carefully here. Whenever you are taking a mass, what is the power it has? Mass means the fundamental unit for mass is kg. So I have taken mass means its fundamental unit is kg. Kg power what is there? 1. So kg is related to mass. We denote with m power 1. And length, if you observe, length we actually what is the unit? Meter power 1. So we denote it as L power 1. And time we are taking here, time is nothing but second power 1. So we have denoting with here T power 1. Like that we'll denote. Now here this powers rise to, the powers rise to fundamental units. The power rise to fundamental units are called dimensions. The powers rise to the fundamental units are called as the dimensions. So suppose you have written that, for example, for area I have taken now. Area means what you will write? Area means you know the units of area. SI units is meter square. So here what is the power rise to the meter? That is 2. 2 is called dimension. 2 is called dimension. Here m is called meter, and here meter is nothing but length. So what we have here? L power 2. L power 2. Meter is related to length, and length power 2 means I can write dimension like this. I can represent like this, L power 2. So like that we are writing the dimensions of physical quantity. Dimensions of physical quantity. So dimension means nothing but, remember, dimension is nothing but power rise to the fundamental unit. Power rise to the fundamental unit is called dimension. For example, you have taken volume. Volume I have taken here. What is the volume units? SI units, meter cube. What's the power raised here? 3. So we can write here the power raised to the meter is called as now dimension. 3 is dimension. So how to represent now? L power 3. Here L3 we can write like that. So here, so the dimensional formula how to write. Now we have to analyze that one. So dimensional formula. What is dimensional formula means? It is nothing but expression showing the, we can simply say expression showing what? Yes, expression showing the powers to which, the fundamental quantities, not all quantities, fundamental quantities must be raised. Quantities must be raised. So, what are the powers to be raised to the fundamental quantities? Keeping in one expression, we call it as dimensional formula to represent a physical quantity. We can also write the definition like that, to represent a physical quantity. So any physical quantity we want to represent, what we will do, we will make the fundamental quantities combination with the powers raised. That is called as dimensional formula. To understand this one, let me take the basic thing is, suppose for example, I am taking the formula as for force. For example, I am taking now force. So whenever you want to discuss dimensional formula for force, we need to have the basic idea of any formula related to the force, any formula. Suppose I can take force is equal to mass into acceleration. So what is the mass? The fundamental unit of mass, kg. Acceleration fundamental units, we know that meter second power minus 2. This is acceleration fundamental units. Mass is kg. So k, these all are now fundamental units. Meter is fundamental unit, kg is fundamental unit, second is fundamental unit. So I can write here m, l, t are there. M is mass, l is length, t is time. What's the power raised here? Kg power 1. What's the power raised here? Meter power 1. So I can write the formula m1 l1. Second is related to time. So minus 2. So the dimensional formula you have to represent like that. The rules are, we are keeping here the square boxes like that. And here MLTR, the fundamental quantities. The powers raised to the fundamental units are dimensions we represent here. So m1 l1 t power minus 2, like that I can write. So now whenever the force they asked us to find dimensional formula, this is the way to analyze. Let us see step by step. First of all, suppose they are asking distance or displacement, or radius. They are asking, or diameter, they are asking diameter. If you observe, all these things are related to length. Everything related to length. That means here, what first of all you have to know SI unit. The easy method is knowing SI unit in terms of fundamental. So fundamental SI unit is what? Meter. So what is the power here? 1. So generally dimensional formulas means we keep the square boxes like this, M, L, T. So I am writing in this way, suppose. Here actually capital M is not meter. Don't get confused. Seeing a small m is there, capital M is there, power 1 is there, you have to put here 1. No. Here capital M is mass. Here small m is meter. Meter is related to what? Length. Meter is related to what? Length. So what should I write here? L power I have to write 1. And what about M? Here mass term is not there, 0. Time term is not there, 0. So this is the way to express the dimensional formula for distance or displacement. Now suppose I have taken, for example, speed or velocity. Speed or velocity. Either you have to know the units, or if you don't know the units and fundamental units, you have to know some formula at least. So I heard that speed is equal to distance by time. Speed is equal to distance by time. So speed is distance by time means distance units is meter, time units is second, or I can write this as meter second power minus 1. So meter second power minus 1 you observe. Now again I have to write the dimensional formula means MLT. Remember here, small m is related to not mass, small m is related to length, small m is meter. What's the power raised to this one means simply I can write 1, so m1. Here capital M, mass related any information is there? No, m0. Time related any information is there? Yes, minus 1. So whenever they use the term speed or velocity, the dimensional formula we can write m0 L1 t power minus 1. Now suppose they are asking for acceleration, or they are asking it as acceleration due to gravity, acceleration due to gravity. If you don't know the dimensional formula for this one, then how to write means at least you have to know some formula related to that one. So acceleration is change in velocity by time, change in velocity by time. Delta V indicates change in velocity by time. Change in velocity also, remember, change in velocity is also velocity only. So change, if you change velocity minus velocity, again we'll get velocity. So here we get here meter per second by time. Time is also second. Or I can write meter per second square. Or I can write meter second power minus 2. So what we can write about acceleration now dimensional formula means observe carefully here. This is power what I have meter power 1 I can write. Now from here dimensional formula what should I write here when I want to write in terms of MLT? M is mass. Mass power how much is there? There is no mass term 0. Length power what term is there? 1. And time power what term is there? Minus 2. So M0 L1 T power minus 2 is the dimensional formula. M0 L1 T power minus 2. So you have to observe here, there is no mass. Kg is there? No. Because meter fundamental, second fundamental, kg fundamental, but kg is not there. So power 0. Meter is there, power 1. And second is there, power minus 2. I can write like that. M0 L1 T power minus 2. So next let us see about now. Already we checked that one. The force formula. Force. Force is equal to, force is nothing but F equal to ma. We know this formula. So again, their force when we are discussing here, mass means kg, acceleration meter second power minus 2. Already I told you this one. Again, for understanding better, I am writing here in terms of MLT. Kg power, what is there? 1. Meter, nothing is there means power 1. So I can write M1, L1, T power minus 2. This is the dimensional formula for force. Dimensional formula for force. So I can write here, this is the dimensional formula for force. So this force dimensional formula is M1 L1 T power minus 2 I got. If I want to find work means here, work or energy, any type of energy, potential energy, kinetic energy, tidal energy, heat energy, light energy, any type of energy or work, or even torque. Torque is also nothing but force into perpendicular distance we can take. So here also torque dimensional formula or work dimensional formula or energy dimensional formula is same. So let me take the simple basic formula for work. Work I heard it as force into displacement. Force into displacement. So I know the force dimensional formula. Just now I derived it as M1 L1 T power minus 2. S is called displacement. S is not a second or anything here in this formula. F is force. S is called displacement. Displacement is nothing but I can write it as L1. So from here you want to construct the dimensional formula means what should I write? M1. L here 1 is there and again we are having 1, 1, 1. We have two things. So what should I write? M1 L2 and time power what should I write? Minus 2. So my dimensional formula is M1 L2 T power minus 2 for what? Or energy or torque. For anything, the dimensional formula is M1 L2 T power minus 2. Okay, I hope you are clear how to write the dimensional formula. Here, next if you observe the next one, pressure. So pressure means I heard that formula. First of all, I know the formula for pressure as force by area. Now force formula just now we derived it as M1 L1 T power minus 2. And what is area formula? What we can write? Area meter square. Area meter square means I can write area means area units meter square. Meter square means I can write L square. So from this information, now what formula I will get means here m1. 2 will go to the numerator. This L power 2 will go to the numerator means already 1 is there. It will go to the numerator 1 minus 2. 1 minus 2 means minus 1 and time power minus 2. The dimensional formula for pressure. Or we can also call it as stress. Or we can also call it as modulus of elasticity. These terms we'll see later about modulus of elasticity and pressure or stress. All the three quantities have same dimensional formula m1l minus 1 t power minus 2. So pressure is force by area, fourth dimensional formula, area dimensional formula is substituted and I got the value here. I hope you are clear with these ideas. So I suggest my students to remember the dimensional formula for these quantities. Every time deriving these 6 quantities is very difficult thing. So you remember, better to remember, that is distance or displacement or radius or diameter, arc length, anything means simply we can write m0, l1, t0, t0, m1, l0, we can write it as t0. So just remember the dimensional formula of this one. Next, speed or velocity dimensional formula m0 l1 t power minus 1. Next, you remember velocity or that is acceleration. So speed or velocity same. Now acceleration or acceleration due to gravity, that is m0 l1 t power minus 2. Next, force dimensional formula m1 l1 t power minus 2 and work dimensional formula m1 l2 t power minus 2. So again, pressure dimensional formula m1 l minus 1 t power minus 2. Remember these 6 quantities. If you remember the dimensional formula, first we have to derive. Already we derived the 6 dimensional formula. After deriving, my suggestion for student is you have to by heart the formula also. First derive and by heart. Don't by heart without derivation better. Because we'll be using often these things in all other expressions, derivations, we'll be using these things. So for that purpose, it is better to remember these things and easily you can access to the objectives. So first you derive them, understand them, then you by heart these 6 formulae also. So that remaining dimensional formula you can have access from these 6. I hope it is clear. Now let us see some dimensional formulas now. Now let us observe that is suppose they have given one quantity like linear momentum. So we heard the linear momentum term, that formula for that one, anything you know means you know mass into velocity. So linear momentum is mass into velocity. Mass is a fundamental quantity kg, but velocity is not fundamental quantity, but I know the units as meter second power minus 1. So my dimensional formula m1 lt power minus 1. Not only for linear momentum, for impulse also same formula. Impulse is nothing but change in linear momentum. Change in linear momentum also momentum. So for impulse they use the term, or linear momentum they use the term. We can write the dimensional formula as m1 l1 t power minus 1. Suppose they told the term as angular momentum. So any formula related to angular momentum, you have to collect. Any formula related to angular momentum. I know even in Bohr's theory also we have angular momentum is equal to mvr equal to nh by 2 pi. M is mass, V is speed, R is radius. So for angular momentum, I have to know some dimensional formula. Mass means I can write m1. Speed already I told dimensional formula L1 t power minus 1. Radius dimensional formula I wrote it as L1. So I can write m1 L2 t power minus 1. m1 L2 t power minus 1. So this is the dimensional formula for angular momentum. Suppose let us take Planck's constant. I think you heard the Planck's constant, the term here. Whenever you take the photon energy, energy is equal to h mu. H is called Planck's constant. So h is Planck's constant and E by mu. Mu is frequency, E is energy. Energy dimensional formula already we derived it as m1 L2 T power minus 2. I told you that to remember the work and formula for some formulas like distance. I told you to remember speed, acceleration, force, work, pressure. These are very important formulae which you will use often. So remember for work, what is the dimensional formula? M1 L2 T power minus 2 here. M1 L2 T power minus 2. So from this information, what I can do here, I have taken the Planck's constant I represent with H. Planck's constant is nothing but what is Planck's constant? H equal to h mu. Mu is called frequency. What is mu here? Frequency. E is energy, mu is frequency. Frequency means nothing but reciprocal of time. Frequency is reciprocal of time, 1 by time. Time period, reciprocal of time period is called frequency. Don't call time, call it as time period. Reciprocal of time period is called frequency. So I can write here m1 L2 T power minus 2. This T will come to the numerator. So I am left with now m1 L2 T power minus 1. So observe carefully here what we got. Here we got m1 L2 T power minus 1 for angular momentum. Now again here also we got the same. That is what the formula we got here. m1 L2 T power minus 1 for Planck's constant also. For Planck's constant also we got the same formula. So that means I can understand Planck's constant and angular momentum both have same dimensional formula. Same dimensional formula for Planck's constant and angular momentum. Okay, these are very comfortable till here. Now let us see few more things like especially the related terms for angular displacement, angular velocity, acceleration, all angular terms. Let us observe now angular terms. So coming to the angular terms here. So when we want to discuss about angular terms. So what will take first one? Angular displacement. Very important. We are discussing about angular displacement. Angular displacement is a special quantity here. You will find some interesting topic here. Angular displacement is nothing but angle subtended at the center when a body moves from one point to another point along the arc A to B, the body travel. Here L is arc length, R is radius. So here I can write theta is equal to L by R. Theta is arc length by radius. Theta is arc length by radius. So here theta is arc length by radius, L by R. So L is arc length, R is radius. Remember here you observe in the arc length is also length. So length means meters, radius means meters. So we don't have dimensions. M0, L0, T0. Why no dimensions, sir? You observe here. L, arc length. Length means related to units will be meters. R, radius. It is also meter. Meter cancel. So we don't have any dimension. But this is a special quantity. This theta is, this angular displacement is a special quantity where it don't have dimensions, but it has units. What has units? What are it units? Radian. Radian is a SI unit. Rad is a symbol for that radian. SI unit is radian. So this is a special quantity which have units but no dimensions. It has units but no dimensions. So simply what we'll observe means generally what we'll observe, sir, theta equal to L by R. No, sir. L meter and meter cancel. So no units. No, we can't say like that. This is the special, so it's also called supplementary quantity. Here it is a plane angle. Plane angle. SI unit is radian. Solid angle, steradian. Now it is a plane angle. We are taking one plane. So this plane angle SI unit is radian. Radian. We do not with RAD. So angular displacement is a special quantity where it has units but no dimensions. It has units but no dimensions. M0, L0, T0. So that is the reason I told it is important, because special quantity it is. Now if you observe now about angular velocity, angular velocity, angular velocity, or they have told it as angular frequency. We also call it one instant of time. Angular velocity at one particular time, we can also call it as angular frequency. Both are same, we can call angular frequency. And we can also take the units of frequency. Frequency. All are having different units, no doubt, but dimensional formula is same. Dimensional formula is same. So angular frequency means omega equal to theta by t. Observe carefully. Angular frequency means omega is theta by t. Theta means radian, time is second. So radian per second. Radian per second. Radian per second means radians. What will have? Radians have any units here? I can write it as radian second inverse. So radians don't have dimensions. Radians don't have, radian is the unit of angular displacement, but no dimensions. No dimensions means only second inverse. S is second. So second is related to time. So m0, l0, t power minus 1. This is angular velocity. Suppose angular frequency I want, then I can call it as omega is equal to 2 pi by time period. 2 pi by time period. 2 pi is having units radian. Time second. So here also I can write radian second inverse. Radian second inverse, dimensional formula same. So again frequency. So the angular velocity, angular frequency, no change here. Angular velocity and angular frequency, what's the relation? If you take theta as 2 pi, and if you take this t as a capital T, that is a time period. Time taken is taken as time period. Then we can write the same dimensional formula for both. So now for these two, suppose I am taking here frequency. Frequency is reciprocal of time period. Frequency is reciprocal of time period. So reciprocal of time period means I can write time period inverse. So from here I can write the dimensional formula as m0 l0 t power minus 1. Here units for frequency and angular frequency are not same. Units for frequency is hertz. Units for SI unit is hertz. So it is not same. Here if you observe the angular velocity radian second inverse. Angular frequency radian second inverse. But frequency units hertz. Units are different. But dimensional formula is same. Dimensional formula is same. m0 l0 t power minus 1. m0 l0 t power minus 1. So your dimensional formula is same. Even units are different. So that is the information about angular velocity or angular frequency and frequency. I hope you are clear. Now, angular acceleration. Angular acceleration. Angular acceleration, what is the formula we have for angular acceleration? Beta, angular acceleration we denote with alpha. Alpha is change in angular velocity by time. Acceleration, change in velocity by time. We know that acceleration is change in velocity by time. Angular acceleration means it is nothing but change in angular velocity by time. So just now we told it is radian per second. Change in angular velocity is also angular velocity. Radian per second by second. So I can write radian second power minus 2. Remember here, radian don't have any dimensions. So what's the dimensions means? Radian don't have any dimensions, only second. Second is related to time. So m0 l0 t power minus 2. m0 l0 t power minus 2. This is the dimensional formula for angular acceleration. Angular acceleration. Now let us observe one special quantity, that is about heat. I have taken capital R. Capital R is nothing but universal gas constant. Universal gas constant. So this capital R is called as universal gas constant. Any formula related to that one means from we know from gas laws and ideal gas equation as PV equal to nRT. Here R is nothing but now PV by NT I can write. PV, P means pressure, V means volume, N is number of moles, T is temperature. P pressure, pressure dimensional formula, M1, L minus 1, T power minus 2. I told you to remember the pressure dimensional formula. Starting, I told you to remember the pressure dimensional formula M1, L minus 1, T power minus 2. And what is the dimensional formula for volume? Volume dimensional formula LQ. Number of moles. Now observe carefully. N is number of moles. It's a quantity of substance. So I have to write it as mole. Temperature, Kelvin. Temperature, SI units Kelvin. So now if you want to write the dimensional formula in the numerator, what we'll get here? M1, okay. L3, L minus 1. 3 minus 1 is 2. L2. And we have T power minus 2. And we have mole inverse. Mole is also fundamental unit. Kelvin is also fundamental unit. So I can represent the dimensional formula like this. M1 L2 T power minus 2 mole inverse Kelvin inverse. This is about universal gas constant dimensional formula. So I hope you are clear. That means here we observe the dimensional formula. Till now we used to observe only M1 L2 T power minus 2. But now we are additionally we observed mole, Kelvin. These are also fundamental units. So fundamental quantities are these. Mole is related to quantity of substance. Kelvin is related to temperature. From that information, I can also write the dimensional formula as including the quantity of substance unit mole and temperature unit Kelvin. I can write M1 L2 T power minus 2 mole inverse Kelvin inverse. I hope you are clear with this formula. So okay, universal gas constant. And somebody asking me what is about universal gravitational constant. Okay, you told about universal gas constant. What about universal gravitational constant? Gravitational constant. So I have to know any formula connected to the universal gravitational constant means I know that gravitational force equal to capital G M1 M2 by R square. M1 M2 are two masses separated by a distance R. Then there exists between any two masses the force called gravitational force. Between every two masses there exists a gravitational force. The gravitational force of attraction is given by F. F equal to G M1 M2 by R square. Now I want G. So what should I write? G means now I can write it as F into R square by M1 into M2. So here F dimensional formula I know. What is F dimensional formula? M1 L1 T power minus 2. And what is the R square dimensional formula? I can write L square. Here M1 M2. M1 M2 are masses. So M1 M2 are masses. M1 is mass, M2 is mass, R is distance. So L I have written. Dimensional formula force I told you to remember. So force dimensional formula M1 L1 T power minus 2. Here kg. So what should I write here? Kg square means mass M power 1 M power 1. So now if you simplify this one, if you simplify this total expression, M1 will be cancelled. One M1 and M1 we can cancel here. This M1 is cancelled. So M1 will come to the numerator. It will become M minus 1. And you observe here, L1 is there, L2 is there. L1 plus L2 is nothing but, I can write it as L power 2. And I can write it as T power minus 2. So, sorry, here L2, L1. We have, what should I write now? I have to write L3. Observe carefully here. L power 2, L power 1, L power 3. So, M1, L3, T power minus 2 is the dimensional formula for universal gravitational constant. What is specialty here? Specialty is nothing but negative dimension in mass. Negative dimension in mass. Negative dimension in Mass. In mass fundamental quantity, we are having -1. Till now, what I discussed everywhere, suppose a mass is there or not there, that is a different issue. But I didn't get negative terms. Only in some terms we are getting negative. One of them is universal gravitational constant. We will observe the other terms also where we'll get negative. So suppose for example, I am taking one term called compressibility. Compressibility. Compressibility, let me denote with C. Compressibility is nothing but reciprocal of bulk modulus. Reciprocal of bulk modulus. So bulk modulus, reciprocal of bulk modulus. Bulk modulus. So bulk modulus is also called as pressure. Pressure. So bulk modulus, not pressure. Actually, it is not exactly pressure, but dimensional formulas are same as pressure. Same as pressure. Any modulus, dimensional formula is same as pressure. So I can write m-1, L power 1, T power 2. So compressibility here also you can observe negative dimension in mass, negative dimension mass. Don't call bulk modulus and pressure are same, but dimensional formula of bulk modulus and pressure are same. So this is the information about the dimensional formulas, basic dimensional formulas we discussed. I hope it is clear. Thank you everyone.